All right, good morning, everyone. Thank you for joining us here today. My name is Chen Harwell. I'm with Devops, and we are here to talk about how you can score your Jenkins build and how that can help you prevent SEV1s or production outages and take you on a little journey that our engineering team back in Tel Aviv underwent. Real quick about me and Devops. So I co-founded Devops along with other folks back in 2012. I've held numerous positions in the company, starting with the head of backend, chief DevOps, whatever that means. And in the last 2 years, I've been running the product management group and currently living in San Francisco. Before that, I was an infrastructure engineer for Autodesk, working on AutoCAD mobile app. And before that, a bunch of other software engineering roles, not that important. So, as I mentioned, we're here to talk about SEV1s in production. Now, just a quick question for the audience. How many of you here actually do interact in some way with your production systems? Can you raise your hands? Engineers, DevOps? Okay, mixed audience. Who had a SEV1 this week? Okay. Who had a SEV1 in the last 90 days? Okay, so that's the majority, and someone who had. Is it still? By the way, is it still active, or you got rid of it? Okay. that sounds nice on paper. All right. So what I want to show you today is how you should be evaluating builds throughout your CI/CD pipeline, and make sure that if given the right data, you can prevent a lot of bad things that are happening in production beforehand, right? We're talking about build stability, we're talking about the code quality, we're talking about preventing stuff that affect your customers. And I'm going to use the term quality gates quite often. I hope you won't get bored with it. Now, for those of you who don't interact with production that much, maybe you're a build engineer, you're a DevOps, but you lack some business visibility. Let me share with you some numbers. Speed and stability are at odds throughout the software development lifecycle. Everyone wants to be faster, everyone wants to improve their velocity, everyone wants their company to succeed faster, greater, harder. However, with all those I deploy 200 times to production a day, you lose a lot of the stability and sanity, I would even say, in your application or in your development lifecycle. Now, on top of that, everyone is an engineer these days. I'm not sure how many of you are interacting with some people who don't really know how to code but end up building software. We've been talking with a lot of enterprises and big customers, and we know that software is eating the world, but at the same time, the quality is not that good. An independent consortium called the CISQ estimated that just last year, the cost of pure quality code was almost $3 trillion in the US. Trillion with a T, not a billion. It's a lot of money. Now, again, you can go to the link and read the report. It's somewhat drastic, but you get the point. We need better quality. And as you all know, if you have a SEV1, your company is at stake, the customers are not being loyal, and it affects the bottom line. So, what organizations are doing or should be doing? First, the whole Devops practices that say you build it, you run it, and increasing the accountability of your development teams. It's important, again, if you're in a Jenkins conference, so I assume this by now is just like obvious, but you need to make sure that your engineers are capable of understanding and owning their stuff all throughout the pipeline into production and beyond. And the next thing that we are seeing is the whole movement of shift left. It started with testing, but again, it's a philosophy. Everything that you could have done before going into production should be done. And that means better testing, longevity testing, and a bunch of other principles. Again, kind of, I'm starting from you already have a good CI/CD pipeline. Now, before I go into my next topic, I kind of want to pause here a second and talk about what it actually means, software quality. You don't really know before reaching production what exactly is the quality of your software, but you do have a lot of breadcrumbs or pieces of information you can tie together. And what you really depend is you depend on good data. You have to have good data in order to make sense or understand, am I building and shipping quality software? And even better, am I improving over time? Now, the conventional way, and I'm gonna ask you in a second, is to use either one or all of these methods throughout your CI/CD pipeline or test suites. You have your static analysis tools, whether it's open source, or commercial. You have the test coverage. Everything is about test coverage these days. And you have your system outputs with log files. Now, we are here to talk about something new, which is taking a look at the output of the system, but closer to what a production run would look like. And that means we want to look at the errors, whether they are new. We want to look at the increasing errors, if I have something that happens more, and regarding slowdowns, if I have performance issues or bottlenecks that I've already seen in my staging environment, well, that's a red herring. We need to fix that. There's no point in pushing that code if we know there is a bottleneck there. So, just kind of summarizing our new approach, we say that a build is unstable or we cannot promote it if it introduces new errors, if existing errors that we never cared about, maybe we thought it's just not important, are happening at a higher rate, or if there's a new slowdown somewhere in the system. Now, kind of putting this into one bombastic slide, I want to talk about something that we call the scoring process. Now, the scoring process, again, as I mentioned, everything is about having good data. So at the bare minimum, we need to detect all of those events throughout the build. Now, it can be testing, it can be longevity test, it can be integration test. We're not so focusing on the method, but on the data, right? So we need to detect all the data, and we need to classify it. So it doesn't help me to have like a, 2 megabytes of log file with all the logged errors in the app. What does that even mean? I need to classify each event that happened based on several criteria. Those criteria can be the type, it can be the tier, whether it's a database, a cache, a middleware related event, and the frequency. It happens once every time that code path happens. It happens every time we're in a specific, database query. We need to classify every event to understand when or where it happened. Then we need to prioritize. Now, prioritizing, again, severity here is kind of mixedly used. What I basically want us to do is I want us to rank all the events that we had from top to bottom, from worst to best, or not worst, or better, and start to reason about what we're actually going to do with the data. And what we're going to do with the data, and the whole notion of this formula that we're talking about, that I'll get to in a second, is to create a score for the build, score for the test. Again, I'm using this interchangeably because in my mind, it doesn't really matter. It's the same thing. You can have a test that runs inside the build, or you have some sort of pipeline that you have a longevity test on. You can say this code is unsafe, this branch cannot go upstream, and whatnot. And that's the whole notion of how do we block bad code from reaching production. And just because we're all have some notion of ops background, we like data to be visualized. So we're going to talk about how do we visualize all of that in a second. Now, detection. Again, I mentioned that you're only as good as the data that you're collecting, and you need better data. And the question becomes, how do I get the data? Chan, you're saying I need all errors. What does that even mean? How can I get there? Talking like science fiction. So today, as I mentioned, you're already using homegrown tools and open source tools and commercial tools to get a lot of data. And you may not even know about all the data that's at your disposal when you build. Let's ask a question. How many of you are actually using an APM as part of testing? You know what, let me ask you this first. How many of you are using an APM in production? Okay, not that many, perfect. But none in testing. How many of you are actually looking at the logs when you run, I don't know, an integration test? Okay, everyone. But do you use Splunk for it? Less hands, okay? But that's my point. We have a lot of tools that were built and used in production, and I'm claiming here that we should be using them as early as possible to get better data about our tests or about our code. Now, kind of diving into classification. Again, if we have infinite time, I think we should be looking at all the events that happened and gather a lot of metadata on them. It can be a Git blame on who actually committed this code change that created this new error. It can be correlating this with all the business units or customers that may be affected, the depending services, the upstream, as well as gathering this nice statistics about each and every event. Once we've deduplicated the event and we know that this is a single event that happens more than once, as I previously mentioned, we can say how many times did it happen, at what rate. And this can be very valuable when we try to make sense of it all. So the next piece was about prioritization. Now, when I say that an error is new, I effectively mean that the type, and we are a Java shop, but take this and map it to any language or framework that you want, right? But I'm sure that all of you, even if you're not working with Java today, know what a null pointer exception is. Let's hope you do. So we can reason about the type or the location where that event happened. And if we keep track of history, which we should, there's no reason why we shouldn't use all the history of all the builds and all the tests that ran throughout time, then we can say that event is really new. And we can also say that it is even more severe, again, I'm using here P2 and P1 just to make it easy on the eye, but think about it as just a new and severe new. If it's uncaught, again, my thread died in the web application, which is never really a good thing in Java, or it's a critical exception. Null pointer exception is not as, well, it is much more severe than, let's say, an IO exception, again, in Java. And we can talk about thresholds, right? You know your app, especially if you're simulating load in a testing environment, you do know what the code was supposed to do. You do know about the code paths, how many invocations they were supposed to have, and you can reason about absolute thresholds and say, this is severe if it had more than, I don't know, 5 instances, which takes me, I was trying not to say dynamic, but actually absolute threshold, because I want to talk about the next piece of information that we think is very important, which is the increasing errors. Now, I'll be honest, not every new error, even though you noticed it, is going to end up stopping your build, because code changes, and no matter how big of your module is, you're probably going to have some false negatives. I'm sure all of you who ran through Sonar or Checkmarks or all of those tools that do any type of analysis have fought hours to clean out all those false claims to make it that if actually bad things happen, then we can stop a build. So this is by no means any different. But conceptually, an increasing error is when the rate of that event is increasing based on the data that I have previously. And it can be the previous build, and it can be the average of the, I don't know, previous 7 builds. And it's greatly, it's severely increasing. Again, I can start saying, I can put some more gates on it. It's 2 times as worse, or I'm starting to run some real-life anomaly detection on it, and I'm saying that, okay, this is a big problem now. Now, I don't want us to kind of go down the rabbit hole of anomaly detection because we didn't have that much of a success early on with it. I think that today we're in a pretty good spot, but we had to fight through a lot of hurdles. So unless someone here says, well, we got anomaly detection figured out, I don't think that this is like the key thing here. And just kind of one sense of it that we fought, and you know, the first thing you encounter that if you start to put some, you try to play with increasing errors, you end up fighting seasonalities very early on, right? Even though, and especially if you're running the same test over and over again, it will scream that there's an issue, but that issue is repeating itself in every build. And if you apply some seasonality algorithms to it, which are, again, much simpler than a full-blown anomaly detection, you're safe. So I would say fight the seasonalities, but don't try and do machine learning anomaly detection on your own. That's kind of what we learned. Slowdowns, I think slowdowns, and again, performance monitoring is crucial, but it all comes down to what we're actually trying to measure. Are you measuring a test? How long does a test run, right? Tests, especially if it's units, we're supposed to run as fast as possible. There's no constraints, everything is mocked. But again, if you think about it, we're not really trying to talk about the unit tests here, but even if we're talking about a long performance suite that runs for 8 hours, then you can either talk about the tests being slow or the system under test being slow and in specific transactions. And that information you usually have, and we say, look at that data. And it's slowing down if you had an average and you did the standard deviation on it, and you can have this nice math that put it in the 95th percentile or something, and it's severely slowing down if it's even worse. Again, I'm not trying to kind of be the statistician here, but we noticed that reasoning about this data and adding it to our computation helped us a lot in preventing it from happening in production. Just a quick example here. We have many tests that call the payment service. And again, I don't even want to read it out loud, but essentially, if it's much slower now, and it's even slower than what it used to be in the last 7 builds, then we have a slowdown. But I'm putting in here, you can look at the deck later. So, what are we going to do with that, right? Up until now, remember we were doing detect, classify, prioritization. Now we need to score. And again, a lot of the things I'm talking here, I'm sure you guys are thinking it's subjective. What does it even mean? How can I take this and apply on my team? So the good news is that nothing is fixed, right? We just came up with a formula, but a lot of it are variables and some are constants. So I'm gonna just run through it. We talked about 3 data points, right? We talked about new errors, increasing errors, and slowdowns. We talked about new versus severe in all those 3. So let's assume that I'm taking each event that happened, whether it's new, increasing, or slowing down, give it 1 point. All the severes, I'm giving 2 points. I'm summing it up. I'm applying some magic weight that I don't even want to kind of talk about. But let's assume we're multiplying that score by 2.5 because that's what makes sense for our team. And we can even push it further in saying that if we hit some key transactions along the way, so those events should hit 5 points. Again, this is going to be deducted from 100 in a second, right? And we can normalize all of that pain any way we want, right? Whether it's the longevity of the test, how much time it ran, or how many tests or how many users we try to simulate. And we come up with a number that you can then use to block the build, right? If you ended up with, let's accumulate all of that, you reach to 30 bad points, 100 minus 30 is 70, maybe that Jenkins build will be yellow. Maybe it's not red, but definitely not blue or green, depending on your theme. And again, this is the point of the score. Now, I've been saying it all along. Your mileage may vary. This is the experiment and experience we've had as an engineering group trying to make sense of our code and our tests. And I want to kind of tie it back with why are we even here and how does that have anything to do with Jenkins, because we're still here. And we've actually open sourced and are using what we called the Code Quality Gates plugin, where all of the prioritization or scoring that I just mentioned are built into. And we have all those fancy score calculations that you can see here. Everything is up on GitHub. I have the references at the end of the deck. And we play with the variables constantly. Every app owner, every service can decide on its own. But you end up with these nice reports. This is a screenshot. I can show the actual Jenkins instance in a second if I have time. This will be one of those red flags. We have the new error gate that failed. I'm not sure if you can read it, but I'll read it for you. The new error gate has failed because we've detected 13 new events, and that crosses the threshold that was defined in the plugin's configuration. Now, Jenkins is awesome, as I mentioned, but people like me who don't deal with code on a daily basis, or our CTO and all the guys in the business side, still care about what's going on in the app. So what engineering did is they also fed the information about each build into a visualization tool like Grafana. So we have this nice widget. Again, everything is open source, and you can hack, use. We'll get to that in a second in the references. But you see, we have the last 5 builds with the data points that we talked about, the new, the increasing, the slowdowns, broken down by meh versus the P1s, the severe ones, and we have a score. And well, the red scores are getting blocked. I am pretty sure that the yellow ones are not getting blocked automatically for now, but the red ones are surely getting blocked and never gets promoted. And again, if you end up using the Grafana visualization and you care about how we got there, we're big fans of the Grafana tooltips. So even though it's pretty dense, you see the calculation here, how we got to the score. You can see that it was introduced 3 days ago. We started from 100, and then we had 9 new issues, 2 severe new, 1 new increasing, yada, yada, yada. Average factor, weights can be configured, but we ended up with 83. Now, kind of summarizing what we've talked in this talk. This has been a great success for our engineering team. I wouldn't be standing here if I thought that by adding more gates to your pipeline actually helps your company. And yes, I'm fairly aware that SEV1, as the gentleman said, has a 2-hour SLA in most places, but some just call every production outage SEV1, even if it affects a minority. And we were able to reduce our SEV1s by 75% in the last quarter by applying these principles. And again, even if you don't take our exact implementation of what that code quality gate means, I invite you to think about what makes sense in your organization, in your day-to-day life, in the data that you have or you can easily get, but you just didn't or neglected. And think about the steps that we took: detecting it, classifying, prioritizing, scoring, blocking it from actually getting promoted, and we feel that the visualization is just awesome. So I'm gonna demo for a second here the Jenkins plugin, just in case the screenshot was not super impressive, but I hope it will work with this Alt tab here. That's not my Chrome. That's my Chrome. All right. Perfect. All right, so again, the overops quality gate plugin is up on the Jenkins GitHub. And as I mentioned, we enhanced it with some more gates that I didn't talk about today that are more specific to what overops data has. Sorry, the data that overops as a company has, which is whether events resurfaced after they were worked on in our Jira integration, whether it's the, again, critical exceptions that we talked about, unique errors, total errors, and whatnot. And the report itself, again, we have some, if I go to the blue ocean, it will look not that pretty, so I'm keeping it with the old UI, but essentially you see that the gates here are either red or green if I see that the data happened. Now, again, this has a whole notion of drill down that I won't get into in order to actually understand what that event is, but I'm trying to keep this talk about the open source parts and the data that Overops, the company, has. And the Grafana bit, I'll need to go into the scorecard to kind of show how that plays. But again, again, this is like a live view of a system. It's a bit more complex with it, what I showed you, but all those widgets are open source, and they talk to an influx database that you can have, again, with this data or your data, and be successful. All right, so that's, I think I'm getting to the Q&A part of the talk. Any questions? Yeah, so you know what? No need to stay on the Q&A slide. We have the Jenkins plugin. It's on the Jenkins CI GitHub page, just as any other plugin. And I posted here some links to the source code that we used as part of a utility library. So the Jenkins plugin will make calls to a utility that does most of the calculations. That is in our, so Takipi is the previous name of the company, so the GitHub is still Takipi, but essentially for the performance scoring or just the scoring that I showed you a snippet from, I posted here links. And you can, if it wasn't clear yet, if you go to demo.overops.com/Jenkins, you can see a live view of how that actually looks like. So the links in my demo were open, no need for email or something to log in to see. You can just go in and look at the data that we have in a demo environment. Any other questions? Yes? I sent the organizers the deck, so I believe that the answer is yes, but maybe the gentleman in the back knows better. Sounds good. But to your answer, of course, none of this is proprietary. If you email me, chen.harrell@overops.com, I'll send it to you in a second. Anyone else? All right, so I'll give you 10 minutes back. I hope you had fun and you learned something and you can apply it in your day-to-day CI/CD pipeline. And again, make great software. Thank you.